I'm Mrs. Mallet, and today we're going to talk about factoring, and more importantly, factoring with your greatest common factor and grouping. So when you have your greatest common factor, what you want to do is you want to look at both terms and figure out what they have in common. What's the biggest factor that can go in them? So my 6x and 18. What's the biggest number in this case that can go into both 6 and 18? Of course, it's 6. So once you grab a hold of that 6, you want to figure out what you have left over. How you figure that out is that you take both of your terms and divide them both by 6. So 6x divided by 6 is just x, and 18 divided by 6 is 3. So that's what you have left over. If you were to distribute that through, you'll come back up with your original problem. Now let's try the next one. What do they have in common? Between 12, 16, and 8, what do they have in common? What's the biggest number they have in common? Right, it's 4. Okay, but now look, all of them have an x factor. There's 3 x's on the 12, 2 x's on the 16, and 1 on the 8. When it comes to variables, your smallest exponent determines what your greatest common factor is. So your smallest exponent, so I have 1, 2, and 3. So 1x is going to be my 4x now is going to be my factor for that trinomial. So you're going to divide everything by 4x. Okay, so everything gets divided by 4x. So 12x to the third divided by 4x is going to be 3x squared. 16x squared divided by 4x is going to be a positive 4x. And then negative 8x divided by 4x is going to give us a negative 2. So when it comes to variables, you want to look and see what your smallest exponent is, and that's going to determine what your greatest common factor is. Okay, so now I have my example with variables here. So let's look for your smallest a. What's your smallest a? My 2 right here. So I have a squared. Now what's your smallest b? Right, b2. So a2, b2 is what's going to be my greatest common factor that I'm going to take out. Now remember, you're going to divide everything by a2, b2. So when I do that, I have a to the 5th, b to the 4th. Remember your quotient rule, when you divide, you subtract your exponents. Okay, minus 3 minus 2 is 1a, and my b's cancel out, plus my a's are going to cancel out there, so 5 minus 2 is going to be b to the 3rd. And then both of those cancel out, which just leaves me with 1 left over. So my final answer is going to be a to the 5th, b to the 4th, minus 1a plus b to the 3rd, minus 1. Okay, now let's talk about factoring by grouping. And I started off with this example here to show you this is what your end result should look like so you can factor by grouping. So you see, what do you see twice in my top example? Right, this y minus 4 is what you see twice. That's already half your answer. So you know your final answer is going to be y plus 4. Now, what do you see left over? What do you have left over? You have the z minus 3. Okay, so let's write that out. So z minus 3. Now you just factored by grouping. So when you factor by grouping, you want to try to get to that step. And then what you see twice is half your answer. And then what you have left over is the other half of your answer. So now I have my last example here of x to the 3rd plus 2x squared plus 5x plus 10. When you factor by grouping, you're going to have 4 terms. And you want to make it in such a way that you have 2 groupings. If you have to rearrange the problem, rearrange it. We already have our groupings here. So I like to look at these 2 as one group and these 2 as another group. So what's my GCF from this first group here? What can I take out? I can take out an x squared. Right. When I take out an x squared, what do I have left over? Well, I have 1x plus 2. Right? Okay. Now let's look at my back group. What is my GCF? Between 5x and 10, they both have at least 5. I can't take out an x because the 10 doesn't have an x on it. Okay, so now let's divide both of those by 5. I have 1x plus 2. Now we're back up here to what I like to call double trouble. What do you see twice? Of course, your x plus 2's. So that's 1/2 of your answer. And what do you have left over, just like how you see it? Your x squared plus 5. So then you write that next. So your factoring of that one would be x plus 2 plus x squared plus 5. Remember, when you're looking for your GCF, look to see what numbers they have in common. And when you start having variables on each term, your smallest exponent on your variables is going to determine what your GCF is. Okay, and then when you factor by grouping, when you get your partners, get your groups, and factor out from those groups. And then after you factor out from those groups, when you get down to what you see here, what do you see twice? And then you're going to write that down, and then what do you have left over? And then you're going to go ahead and write that down. So today we just talked about factoring your greatest common factor, or GCF, and factoring by grouping.